Before digital mixers could store thousands of scenes, there was this. The TEAC Model 5, an 8-channel recording console built for the Studio 8000 system. 8 microphone preamps, 4 mix buses, 2 auxiliary sends, control room and studio monitor feeds, tape returns, direct outputs, and routing flexibility to build a serious recording studio around it. Around the back, you'll find balanced XLR microphone inputs, RCA line connections for tape machines and outboard gear, direct outputs for every channel, bus outputs, aux sends, monitor outputs, and everything needed to integrate multi-track recorders like the TEAC 80-8. But after nearly 50 years, age catches up with everything. We'll show you our recap process, how to safely remove components without lifting the delicate circuit board traces, clean decades of oxidation from scratchy pots and switches, replace noisy IC amplifiers, including some that are dead. We're going to install new LED meter lighting and undo a few interesting modifications left behind by a previous owner. We'll also replace every channel fader but one with modern Alps faders, bringing back the smooth feel the console deserved from the beginning. And finally, we'll install our direct output modification, adding pre-EQ and pre-insert recording options alongside the factory post-fader output, making this Model 5 even more capable while preserving everything that made it special. Let me show you how we brought this classic console back to life. I'm going to end up recapping every one of the modules in this board, but this isn't really going to be about recapping. This is going to be about technique and getting the capacitors off of these boards without any collateral damage. Oh, what do you mean? Well, you take a look at this board here. This is from the mid to late 70s, but this technology, as far as this material they used for the circuit boards, the issue is going to be with the circuitry and the printed circuit foil runs and the solder pads that are actually on here. What do you mean by collateral damage? Well, if you look here, what I'm showing you is a solder pad. Now that would have been attached to a foil run, and it's so thin that it literally will just break off. Or when you go to pass the component, the lead for, say, the capacitor, through the hole, the lead may actually snag the hole and push that solder pad off. Once it's broke, it's broke. I want to show you how to avoid, as best as possible, that happening. These leads for this capacitor, when they slipped the capacitor through there and the leads came through the hole, they bent the lead for the capacitor flush with the top of the board. And these circuit runs here are going to be the issue. So I have to come at it in such a way that I'm going to get most of the solder out off the board without taking the pad with it. Okay, because the heat is what's going to affect whatever kind of adhesive there might have been as far as keeping the foil run attached to the board. I'm going to put my index finger on top of that capacitor on the other side. I'm going to just hold the whole thing with my thumb. When I get that solder loose, I'm going to start wiggling that, maybe even trying to draw a circle with that capacitor. Because that lead in that hole is still moving and cooling, okay, it won't attach to anything, and it'll be perfectly loose. 19 times out of 20, this technique will work, all right? The thing you don't want to use on boards of this age that are brown, do not use solder wick. Now, I live and breathe by solder wick, love solder wick. I like the way it works. You know, you heat it up and watch it just form and everything like that. Some part of it is going to adhere to that pad, and the moment you pull the wick off there with the solder you removed, you just pulled the pad with it. When you go to do the second lead, because the first lead is loose now, it's going to be easier to draw, a circle with your finger around that thing, keeping it totally disconnected from everything. There it is. Okay, those capacitor leads are laying down, and they're laying over and laying up and pointing up and all that stuff. Okay, what you do is you simply take the capacitor, immobilize it with your finger, okay, and then just very gently grab the tip of the lead of that capacitor, which is not totally cooperating here, but just sort of get it pointing straight out. Then grab this lead up here, sort of straighten that one out, get any bends out of it, because that's as crooked as a dog's back leg. That's good right there, and this capacitor just comes straight out. Yeah, see right there. That lead on that capacitor was so short, but I can see where I pulled just a piece of that foil pad right up off the board. I think that's because it's technically still soldered to that lead. You look at this pad right here, and it is all kinds of boogered. Electrically, it's probably still fine, but this is the case where putting a new capacitor in there and pushing the lead through the hole in order to get to the solder pad on this side could snag the pad and actually tear it right off the foil run. This is the one spot that I'm absolutely going to check for continuity when I'm done. Just as I had suspected, pushing that capacitor through there has just pushed that foil pad right off the board. All right, I'm just going to go ahead and put my thumb on that pad as I pass that lead through there. It's not a bad day. It's not a deal breaker. What I would end up doing, if that actually came to pass, then I would take this lead and actually just bend it the other way, follow this foil run, cut it off right about there, and then just solder that lead to this solder point. It'll achieve the same thing. Now that I've got the leads through there, I actually need to decide how I want to bend the leads to keep the capacitor from falling out. Bend those a little bit like that. That's where it stays. The reason I want to do it that way is because I want to get all of the capacitors in there, basically grab the iron, and I'm just going to solder, and just get them all done all at once. And then I can move on to checking continuity to make sure that I haven't actually created some form of collateral damage. Now we check for continuity. And it's good there. Now, this particular solder point, it actually is kind of in the middle of a run, because the solder point for that capacitor goes this way, probably to a resistor, okay? And then it goes this way, which actually comes down here to, well, the collector of that transistor. And so we're gonna check both of those destinations. This one down here, collector, good, so that one's done. This last point, right down here, all right, is where I took that capacitor lead and actually piggybacked the foil run to what they're calling pin 40. And it do. Those 8 are done. You can finish this off by clipping that off of there. Now, I'm going to have one short because I actually used that lead as a foil run. Now, we'll just get this all buttoned up. There we have it. That's all ready to go back in. Let me go ahead and just pop that in, and then excuse myself for a smoke break, pronounced coffee break. See you in a minute. Surprise! Let me show you something. You know, you end up on high alert, red flags, buzzers going off, and all kinds of things. Well, I want to show you this. This is what somebody thinks is a necessary modification. You've got a resistor hanging up here. We've got a resistor down here riding piggyback on a resistor that's actually still installed on the board. And it is in fact labeled, at least, the correct value. Well, as we look at the schematic, what's going on right here is that this resistor right here was deemed inappropriate for the circuit as it was in use. And unfortunately, that resistor is part of this actual voltage divider network that exists on behalf of this particular op amp. So the feedback loop for this op amp, which is what determines the gain structure, okay, takes the output of the op amp, goes through here and goes to that position right there. And it also will, depending on this switch up here, will actually then go through this resistor and on the way down. But at the same time, it's working against this resistor right here, and lo and behold, this pot, which is the trim pot. That is how the module is going to be selectively attenuated. You know, you've got a position for 0 attenuation, minus 20 attenuation, minus 40 attenuation. The question then becomes, well, what were they thinking? This module was being used for videotape duplication. Okay, well, that is due in large part to the fact that there's actually 2 inputs for each module. One of them is going to be a line input, which in this case is an RCA jack for minus 10 dB, or you've got a microphone input, which is going to be somewhere in the neighborhood of 55 dB down. But that microphone input is also an XLR input, like a typical microphone would be. Doesn't have phantom power, but a broadcast 1-inch machine Type C professional is going to be XLR. Got it. Okay, but it's also going to be line level at plus 4 dB reference. So they were using the XLR input, which in this module is for mic level, and they were using it for the 1-inch machine and couldn't get enough attenuation from the mic attenuation switch, which again is 0 or 20 or 40 dB down. I happen to know that Sony U-matic machines had a lot of different model numbers, but there was a 5800 and there was a 5850, and they were all line outputs. No XLRs on there. RCA connectors. And the RCA connectors would have gone into the line input for this module, and the 1-inch machine is then relegated to the XLR input, but it's breathing fire. It's just overloading this module. I can understand what they were thinking, but I do not agree. If the signal coming from a VTR is too high, then you take the XLR connector, you then take it apart, you build an H-pad inside the connector to take that line level to mic level. You're going to actually drop that somewhere in the order of 65 or 70 dB. But you use resistors to do that. You don't make changes to the audio board. The schematic actually shows that that resistor is supposed to be 820 ohms. Well, buried underneath here is an 820 ohm resistor. That's what's supposed to be there. But then somebody has also soldered a 3900 ohm resistor, which is almost 4 times the wattage. I mean, what are you trying to do? You know, I mean, you don't install a cigarette lighter on your audio board. And then they've got this thing hanging out here, which is 560 ohms, and they're all in parallel. Ohm's law is going to be in the neighborhood of 820, 390, 560. It's going to be like 300 ohms. So what they've tried to do is just change the gain structure of that op amp in order to attenuate the signal enough to be able to feed it an illegal signal. All right? And, you know, when it comes to illegalities, I really don't have a lot of room to talk, but this is just oh, the F word. Yeah, the F word, flagrant. That's not really a legal value because that resistor network is actually still in the circuit, so it's being affected by components that are adjacent to it. So I totally get that. Gosh, there's so much solder in here. There, come on. This is just... This is the case of when, you know, when you say somebody's got enough knowledge to be dangerous. I mean, one of the reasons that you don't put modifications like this permanently inside of a console or a machine or whatever is because it's out of sight, out of mind. What ends up happening is that just lives in there forever. And what happens now when somebody were to take that board, let's just assume for a minute that this is like close to 40 years ago, and somebody says, hey, you want somebody that board? Great, buy that board. And then they take it home, they plug microphones into it, and they don't work because, well, they
ask you how you are, and you just have to say that you're fine when you're not really fine, but you just can't get into it.
Because the attenuation is so high. I mean, they're attenuating a microphone input 70 dB down. It's missing a screw. So clearly, this has been worked on before. Someone made up a rule one time that, you know, it was like, well, you know, if you're a really good engineer, you'll have more parts left over at the end of it and it still works. Okay, that's the mark of a good engineer. But now we've discovered where some of those parts should have gone. And I'll be honest with you, this other screw that feels as though it's stripped, I'm probably gonna have, that's not coming off of there. I think I have understood now why whomever actually took and just built a solder network of resistors on top of R20. They could have just taken and removed that resistor, but they couldn't get underneath the board. Why? Because they stripped out the last screw before they could actually get the whole board loose. With a screw with a stripped head, they weren't going to get the board out of there, so they just went ahead and did it this way. So it was like, you're already doing the wrong thing. You did even more wrong. You stripped the head trying to get the whole thing out in order to do the wrong thing, and then you just basically piled on with doing more wrong thing. So this screw gets a place in the most valued of places for screws that are no longer any good. Now, we'll just send it home. I'm curious to check how that attenuation behaves now that we've taken out all of this criminal activity. Run some tone through that module, number one, and compare it to at least two others. I've set all of the gain structure the same. The faders are all in the same place for 1, 2, and 5. The gain structure here, the attenuation is set to 0 with 0 attenuation on the switch. This is channel 1 with tone, 0 dB. All right, and just comparing that to channel 2 with the same settings. EQ is flat, by the way. Okay. Channel 2 is a little higher by about 0.5 dB, which the accuracy of this board, that's pretty damn good. All right, and then just for random shits and giggles, all right, channel 5, okay? Actually, channel 5 is closer to 1 than 2 is. So, 1 equals 2, 2 equals 5, 1 equals 5. Basic algebra, we're in the ballpark. But let's treat ourselves to a diversionary tactic. The meter lamps. I noticed that when I was working on this before and powering it up, well, none of the meter lamps are any good. And there are 5 of them. 4 for these meters here, and then this little smaller meter back here, which is the Q meter, echo. You know, you can monitor the actual levels of the things that you're sending out of the board that are not really part of your real production. Let me show you where we're at. This is the line that goes to the edge connector that is on what I would call the motherboard back in there. All of these buses and so forth that are going there. Well, it's calling for 6.5 volts. Well, my input voltage right now is 115, so it probably really is 6.5, but I can tell you that I have only measured 6.2. All right, is that important? Probably not with just 0.3 of a volt to deal with, but I want to convert these bulbs to LED strips. These are incandescent in color, about 2500 degrees Kelvin, and these of course are strictly DC. Well, as it turns out, so is the power supply for the lamps. So all I'm going to need is really just one resistor. I'm going to be using a 0.5 watt to power all of these LED strips, which don't draw any current hardly whatsoever. This is going to be a 470 ohm resistor for all 5 indicators that are going to go inside the meters. It's going to be accessible to the point where all I have to do is change out the one resistor. If I want to make them a little bit brighter, I may drop that down to 390 ohms. I doubt I'm actually going to go up because they're already dim enough to not be a problem, and I just want to see how it's going to look. But we've got to get these in there first. I want to remove the meter cover, this lens, this bezel, okay? I want to lift it out of the way this way because I want to protect this alignment screw, which is used to zero the meter once we're done. What I want to do is I just want to lift this meter face off. There is a tit right here, and there's one back here, and there's one on each side. So there's actually 4 of them. But once we get one started, it will pretty much want to pop off on its own. But I don't want it to pop off because I want to control, yeah, like that. okay? Because I don't want to risk damaging the meter movement or anything else that might be going on in there. I'm just going to quickly check to make sure that I haven't really affected the meter movement, okay? So, yes. All right, so that's still in good shape. Right here is the actual meter lamp, okay? And it's soldered to these two spots here with foil runs that go to these leads, which lead through the back of the meter and out to lugs that are soldered onto from the power supply. The first thing to do is to just go ahead and get that old dead lamp out of there. And I don't want to have this bump into anything, including the mainspring that's part of the meter movement or anything like that. This solder tends to let go very quickly, which is kind of nice. And I'm just going to go ahead and grab this here so it doesn't fall. It's out. I've already determined that this is the positive side, this is the negative side, and good thing too, because in these meters, for whatever reason, the lead for this power point is red, and this one is red. What I am going to do is I'm going to tin these ends, but I'm going to do it very, very quickly because I don't want to risk heating this beyond necessary just to get the solder to tin on there. I'm actually not going to solder it to this point where the bulb came off because the bulb was short enough to where it just needed to be that long and that far apart, and that's all well and good. What I am going to do is I'm going to solder to these outer points because this is so long. I want to do this in such a way that this opaque part is actually going to be pointed toward the meter face, illuminating it this way because there's less illumination from the backside. And although this is kind of a flat spade-like metal solder point, I'm actually going to solder it to this point, but vertically, okay? Instead of laying it flat and soldering it there, I'm actually going to stand it on end and solder it. That way, this opaque part, which is on the flat part of those lugs, okay, is actually going to end up facing the meter. And I'm kind of doing it at an angle because I've already kind of measured and figured out that really that angle right there is exactly what I need to accomplish this. Now, there's these little stops right here that stop the meter from moving, okay? This little white gizmo here, which is just a little piece of kind of ceramic maybe, or maybe just a piece of plastic, that the meter is prevented from going too far to the left, okay? But by the same token, there's another one over here that prevents the meter from actually going too far to the right. I am going to tuck this in behind this pointer stopper. Then I'm going to go ahead and dress it up and around this area here, and then coming right back around the meter stopper on the bottom end. That's the way it's going to look. So now all I have to do is solder that last lug in place, and I'm not risking the meter pointer in the process. I've got more of a loop over here than I have over here, so I'm just going to just very gently put my finger over the top of that and pull this way to try to even that up. Okay, and when this LED strip is right passing over that screw head and this screw head, I know it's got to be pretty close to even. One more check. Okay. Now the actual meter, see, that's called the meter face. This is the cover, bezel, escutcheon, window. I like window. While this is out, I'm going to go ahead and just clean it up because it's got fingerprints and dust and it's all covered in germs. Now, as old as this is, you think, well, okay, probably ought to wipe down the inside as well, but these things, they just don't get any real debris inside of them, okay? But at the risk of making an assumption, no. Quite frankly, at this point, I'm just going to go ahead and do all of it. Be very careful of this little stem that's right there. What that stem does, when you put this face back on, that stem fits through this slot right here. Okay? And then as you rotate it, this piece will move back and forth, and it adjusts the 0 point of this meter. And when I say 0, I'm talking about nada. I'm talking about no signal, all right? Because there's this one little line below. I gotta get my official 6R pointer here, okay? This first line right there, okay, well, that's minus 20 dB, but there's this other line just south of that. That's 0, okay? That's what this is for. With that pin pointed down, I'm going to not let this edge here actually touch yet. I want this part here to actually begin to bottom out against the frame of the meter bridge. And then while I'm holding this face, keeping it immobilized, what I want to do now is turn this just about 45 degrees either way, okay, until it engages the meter. Now I've actually got control of the meter because that pin is in there making that arm slide back and forth. Get it to where the meter is in a spot, it's moving, and then I back it off just a little bit to make sure that that pin is actually centered in that area. Now I can safely just go ahead and snap this meter face back onto there, okay? And with all of that done, now I can actually set the meter to 0. And we'll just take a quick look at that. That's what the meters look like, okay? This is off, and this is on. Cool, huh? I have it on good authority that those LED strips are going to outlive the board. Making a list, checking it twice. Gonna find out what the hell was I thinking. Well, let's find out. Let's see if I can't demonstrate some of the things that are going on here. I mean, everything seems to want to work, but when you look at it with a critical eye, it's not as pretty and is going to require some more TLC. So, but what I want to do is just play a track for you, and boom. Cool. All right. So I've got some audio there. One of the things that I wanted to point out is that the pan pot right here, okay, when it's assigned only to group 1, well, group 1, pan pot doesn't do diddly. I mean, the best word for the way they operate is kind of like a matrix, okay? Because with only one button pushed, it's only going to group 1, and consequently, pan pot doesn't do anything. It shouldn't do anything, but press 1 and 2. Now I've got the pan pot at 12 o'clock, and I've got audio channels 1 and 2 activated. I can go to 1, which is actually going to move everything over to the left channel, and then with varying degrees all the way to the right channel, which is 2. The reason for that is because groups 1 and 2 are panned left and right respectively. Now I can change these around and actually feed the left channel. Even though I'm feeding group 2, I can send that over to the left channel. So that much is working. I mean, and it looks and sounds pretty good. Channel 1's going to assignment 1, group 1 to the left channel. Beautiful thing. Okay. Channel 2 is going to group 2, which is panned right, and I can see the stereo image on the scope. So that much is working. What I've also done here, though, is I have duplicated for all 8 channels from one stereo source, basically left, right, left, right, left, right, and so on. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, left, right, 3, 4, left, right, 5, 6, left, right, 7, and 8, left and right, okay? And that again is because of the panning situation of the actual groups. This board is not capable of sending anything directly to the actual output. And by the way, I am coming out of the control room output, which is controlled by a pot right here, and it's not entirely happy. There's some obvious scratchiness going on there. And I've noticed, if you did too, that the switches, the assignment switches, tend to be a little bit scratchy as well. When I'm using an audio signal, music, you know, get down, get funky, get back up again, well, the music is too intermittent, it's too variable. So what I really need is a steady state tone, which is going to be irritating beyond belief. But I'll try to minimize that, but really what's going on here is I need to determine switches, scratchy, pots, scratchy, and so forth. And in order to accomplish that, I want to go ahead and put a tone into the same input. And what I want to do first of all is I want to calibrate the board, okay? I'm using a minus 10 dB 400 hertz tone, and I want to just go ahead and set these meters to 0 dB for that minus 10 signal, okay? And I'm going to use single tone in one channel and simply go to different inputs driving the groups. 3, 4, 0. Now I've got the group faders at a calibrated level. Kill that, go to channel 2. There's sort of a dot matrix gray field between 7 and 8 on this fader travel. So I'm going to use that dead center at roughly 7.5 to set my levels all the way across. I want to use the same subgroup channel for all of the fader calibrations. 1 through 8, going to group 1, 2 to group 1. Boy, that one is just, that is nasty. Okay, so these channels here are fairly well calibrated to 0 dB on the VU meter, okay? Now, what I also want to do is to make sure that these groups are set to where they need to be. And these, what they call monitor gain, are these red knobs here, okay, which basically take the groups and feed them to the actual 2-mix output, all right? I'm calling it 2-mix. TEAC calls it monitor, okay? And in colloquial terms, monitor means monitor, not mains. Nowadays we'd call it mains. There was a time where it was called a 2-mix because everything that was done that was mel mixed together went out to 2 stereo channels. 2-mix works for me, but at the same time, this board is capable of 4 discrete channels output in order to basically marry this to a TEAC 40-4, a multi-track deck. So having been able to do that, 2-mix is not entirely accurate, but it does count for something. So with taking the tone on channel 1 and feeding it to group 1, I'm confirming the actual calibration there. 2 is I'm just a little bit high, and 3, again, just a little bit high, and 4, good right there. So, consequently, turns out there's a problem. Okay, I'm going to go ahead and put the music back on because right now it's not going to matter a whole lot what our source is. The problem is that the studio output, which is actually supposed to mirror the control room output for left is left and right is right, doesn't quite work that way, okay? Because what I have found is that the left channel is dead. That's a problem. And they're coming from the same place. One other thing I want to point out is that each of the 8 input channels has a direct output, okay? I've got all of these, the stereo source going to the line inputs, and then there's a direct out for every one of those inputs. As we all know, a direct output is basically the signal goes in and comes directly out. the direct output should only be affected by the input attenuation. Wrong, -5, thanks for playing. I'm just going to go to the direct outs, which is going to simply be the stereo signal coming back out so that you can hear it. But here's what happens. To feed the direct out, you have to press down the two buttons here for left and right, 1 and 2, in order to feed the direct out to the direct out jacks. All right, so those are pressed. I've got an input signal here. Here we go. That's not supposed to happen. That's not supposed to happen. Direct out should be pre-fader, pre-EQ. Well, is it pre-EQ? Let's find out. So it's not. It's not pre-fader. It's not pre-EQ. It's actually post. Everything. Anything that I do to adjust EQ or change the fader or even the attenuation affects that direct output. So in my opinion, it's really not a direct out. So what I propose to do is that I'm going to pull each of these modules, which I was going to pull anyway in order to be able to clean them. But what I'm going to do is I'm going to make a modification to the actual modules themselves, because this push button, when it's down, it's actually tapping a signal from after the fader and after the EQ, and it sends it out that direct output. But when that button is up, it actually is shorting that direct output to ground. What I propose to do, let me show you. Here's the direct output, okay? And that's what we're looking at right here, okay? This direct output, that one, just go 1 through 8, okay? But what's ending up happening here is that this switch right here, okay, is that direct out switch. So as we look at this direct out, okay, is going to be going through that switch to that spot, and then all the way down here, all the way to here, and it keeps going to ground. I'm going to go ahead and interrupt the foil run right there, okay? I'm going to open that up, and then from this up position, I'm going to take and run a line from that spot over to here to that spot. And what that's going to do is it's actually going to take the output for that direct output from this op amp right here, because that op amp is going to be in front of all things, the fader for that particular channel, all right? But then by being in front of that fader, it's also in front of all of this right here, which is the EQ adjustments for that particular channel. So by tying into all of that, it's not going to be affected by the fader or the EQ. But here's the beautiful part, okay? By not actually doing anything else to that switch, what's going to happen is that when you push the switch down, it'll be post fader, it'll be post EQ, just like it always was. But now, with the switches up, I'm actually going to have a choice for pre-fader, pre-EQ. And what comes out of these direct outputs is going to be raw. And that's what a real direct output is, in my opinion. So I've mentioned that the control room output is what they call monitor. All right, again, it's basically the stereo output. The pots and the delegate switches are all dirty. They need to be deoxidized, okay? And that studio feed, it's got a dead channel on it. And, you know, I've done a little bit of homework as far as that's concerned. For whatever reason, TEAC is using a completely different type of amplifier for the studio output as opposed to the control room output. The control room output is up here, okay? And the control room output is using this op amp and this op amp for the left and right channel outputs. Studio output is using these two amps. They're not even really op amps anymore. There really is no way to use an extender card on these. I don't even think extender cards exist. So what I did was I soldered onto the input right here and right here. I just put a couple of leads on there, soldered them onto those pins on those amplifiers and checked them on the scope. And the signals are both there. They're exactly where they're supposed to be and they're exactly the right level they're supposed to be. However, this output here on this, which of course goes through that cap, is dead. This chip is shot. This one checks out. It kind of baffled me a little bit because I was trying to understand why they would use a different amplifier. Well, their intention is for the studio feed, that they call it, is supposed to go to a 2-track mastering deck. Okay, when you basically are finished doing all of your mix down and your bounces and all that, and you're going to feed it out to a 2-track deck, but there's a pot for that. You can actually change the gain, just like it was a volume control for headphones, which is right up here. All right. Well, the studio feed is adjustable, which means I just think that's dangerous. All right. You're mastering something and you think you're grabbing the control room knob, which is right nearby, you know, because you want to turn the speakers up a little bit. All right. So, and then you grab the wrong knob and you just changed your 2-mix mastering and you got to stop and start all over again. So I don't really care for that because that pot will change the studio feed. And then they used these other op amps, amplifiers, to, you know, feed that particular output different from the control room outputs. I can only guess that they did it that way because they wanted a hotter signal, okay? But even that doesn't play out. As it turns out, these op amps up here are minus 2.2 dB. Well, it's the same thing for these 2 amps right here, although that one's dead. This right channel down here is supposed to be minus 2.2, so it's the same gain, but with a much beefier amplifier. And when you see it, you'll know what I'm talking about. I mean, the ones that are on that board for the studio feed, they have heat sinks on them, for crying out loud. So the others for the control room output don't need heat sinks. They're still developing minus 2.2 dB. So it's a head scratcher, and I'm not going to try to figure out what they were thinking. I'm just going to make it work. Here's where we're going to be working. These are the buttons, obviously. This white one here is the direct out. So in the up position, it's shorting out the output to the direct out connector, all right, which is actually going to be this pin right here. This pin is the wiper for that switch. Now, this is the single pole double throw side. This is a single pole double throw side. But here's where it gets interesting. And this is why the schematic is a good thing, but you got to be mindful of this, all right? What TEAC in the design of these circuit boards has done is they know that that side of that switch isn't being used. That single pole double throw on this side isn't being used for anything. So they went ahead and used it as a solder joint, okay? Because everything that's supposed to be grounded here, all right, from here all the way through here and then across there and down, all of this through here is ground. And they just decided, you know what, we need to use that, so we're going to go ahead and use it. This is the pin right here that we need to work on, okay? This pin right here is the direct out switch in the up position. And what I'm going to do in order to accomplish that is to go ahead and open up the foil run right here, and I'm going to open up a foil run right here. And here's the rub. All of these other pins down here, okay, everything goes down here to ground. Now, I need to continue the ground circuit because all of this other stuff down here needs that. Or maybe it's going in this direction. It's ground. So ground is ground is ground. So from this point here, back to the ground on this side, I'm going to put a jumper, just to make sure that I have maintained the integrity of ground through there. Maybe maybe parts of the circuits are getting ground from somewhere else. I'm not going to make that assumption. I'm just going to go ahead and know that I interrupted it here, so I'm going to reestablish it, but I'm still going to isolate that pin. What I like to do is just make 2 scoring marks next to each other, and then just take the blade and sort of just dig into this right here and lift that foil out of the way, okay? And in a moment we're going to check the continuity, but I'm going to go ahead and do this other spot right here. And open that up, okay? And actually, you saw it, it slipped, and it took out some more of that foil than I wanted to, but it accomplishes the same thing. It's not a big deal. So this is going to test the point that I want to isolate, okay? And now I'm going to just start with the actual wiper of the switch. I should get continuity there. The button is up, and I do. But I'm going to come back this way. That's open. And going this way to this spot right there, it's open. So that part of the mission is accomplished. Now I can go ahead and actually finish the modification. But in all fairness, I want to do this first. I want to go ahead and reestablish the ground that I have interrupted. This ground is that ground. And this point, this switch right here, this switch point is isolated. But it needs to have a signal, which has got to come from that op amp that I pointed to a little bit ago. And in fact, I'm actually going to end up weaving this wire because I have to get up to that spot right there. I got to tie this all together to the switch at this spot. Yes, the wire gets warm when you're soldering it and you're holding your finger on there trying to immobilize the wire. Yes. It'll get your attention, but if you don't flinch, then you can actually complete the task at hand. So, that much is done. It actually, I think it takes longer to take this apart and put it back together than it actually does to do the modification. So, just a little bit ago, I mentioned and demonstrated to you the scratchiness of some of the pots, you know, the pan pots, you know, they're just scratchy. And it's not surprising for as old as this is. And I'm going to start with this main monitor board with the studio feed, the control room for your speakers and so forth like that. What I want to show you is where to use some contact cleaner. This is not exactly deoxit, but it is virtually the same thing. It contains naphtha, which is going to not degrade any of the moving parts, but it is going to clean the wafer portion of the pots and the contacts of the switches. And I'm going to use this 4-gang pot in order to demonstrate how best to get inside here. There's a gap. Now, not all pots are going to have this gap, but there's a gap right here which is actually open to the interior of the pot. So there's going to be a part of that pot that's going to have a wafer that runs around this way, and then there's a wiper that runs around that to vary the ohms, the resistance in this particular pot. Well, that's what you're aiming for, okay? And then there's the next gang up, which is here, okay? And then one in front of that, which is there. Then one way back up in here that is going to be for the last gang. So what I want to do is keep the can vertical, but I want to be able to reach down inside there while keeping the can vertical. I'm going to just hold it in place, cover this up so it doesn't spray me, and just that much, okay? Now, you work that back and forth. That's all you got to do. For the headphone gain, cool. And this one, I can even see that it's wet in there. I can see the actual framework that's actually holding the wiper that is going to be moving attached to the shaft of the pot. All right, so moving along, because this can go pretty fast. Some of that oil is actually running down in here, and you can see how wet it actually looks back in here. As little as I'm spraying it, there's still plenty of overspray and just leftovers. Switches need contact cleaner as much as they do lubricant, right? So we're just going to go ahead and spray that, but there's a switch right there, all right? And this is the actual internal body of the switch. So and what's happening is there are lugs on the back of this switch. And what happens is there's a wiper that will wipe between. So it's basically a single pole, double throw switch. And that wiper has got to be making contact between these contacts, and then maybe no contact, and then this other contact, which would be down here. So the idea is to go ahead and clean these contacts that are going to be part of this Bakelite base right here. And then also lubricant is going to allow that part to slide inside of this whole area. Spray this in there, okay? And then just work that switch back and forth. What I like to do is to just get it, spray it once, move the contacts. It's going to break some of that oxidation up. It's going to break it all up. And then one last douche through there, just to kind of blow out what might have come loose. Okay, taking advantage of the lubricant. Moving on. Now, honestly, the best way to do old faders like these would be to go ahead and pull this escutcheon all off, pull the screws out that are holding this framework in here. But there's like all of these leads that are basically going back to the groups there, and so it just turns into a lot of wires and so forth like that. But sometimes what I would like to try to do, there's a rivet here, and then at the very top is more rivets, okay? Those are holding the wafer on this end. What I have had to do in the past even is to go ahead and pull this whole assembly out, pull these tabs up, okay, so that this whole back falls off, all right? But the problem that comes with that is that these tabs weren't meant to be unbent and then bent again, okay? They literally, they're good for one bent, and that was 50 years ago. I mean, I want to do something. So I'm going to try to go ahead and spritz in there just enough to get this fader lubricated. I'm just going to go ahead and spritz this down in here. With any luck, I've got some sprayed inside there that I can spread around. And honestly, that should take care of it. Now, this particular board has got pots, it's got a switch, but it also has one of these push button switches, okay, which is a complete departure from the slide switches, which are kind of up here. These are going to be a little bit harder to deal with because they're virtually sealed. Right there is where I intend to go in. Yeah, and I mean, it went everywhere, but and with this single gang fader, all I'm actually going to do is I'm just going to go and spritz it just inside here. All right. I've actually done this before and sprayed into a fader like that, and when the chemical came running out of there, it actually was dirty. I'm gonna go ahead and wipe down some of this excess here, otherwise when I put this module in, it's gonna just drip all over the inside of that cabinet. What that will do is if there is any kind of dust buildup over time and everything like that, this material, this oil, is just going to give the dust and dirt something to cling to and build up on. So it's a good idea to just try to get any of that overspray off of there. Now I want to do one of these input modules, but dead spider. The solo button is momentary contact. That is done. And just to prove that we intend to actually use this mixing table, which is more like a nightstand than a mixing table, but I'm going to invoke the F word. That's right, gang, faders. Okay, could have used the P word, potentiometer, but as we've all come to expect, that the F word is for faders because it controls the gain of a signal. Okay, now that said, the faders on these modules are like rubbing two bricks together. I mean, it's just, and I've shot these things full of contact cleaner and lubricant, and since you really can't appreciate what's going on, it's not like, you know, well, but something smells bad. You don't know that for sure because you're there and I'm here, okay? But yeah, maybe I can smell it. Well, you really can't appreciate exactly how much effort it takes to move these faders, okay? Yeah, they move, but again, it's like rubbing two bricks together. And so what I want to do is I'm going to demonstrate for you exactly how much effort it takes to move faders, and you'll have to take my word for it, they're all just as bad, okay? Or maybe they're not bad, maybe this was expected, okay? But they are what they are, and you're trying to make a little adjustment to an audio thing, you know, and it's like, okay, that may be what was good, you know, 50 years ago. Not so much here. We're gonna replace the faders, and I'm gonna show you what we're gonna replace them with. We found these on the interweb. These are, quite honestly, very, very, very good. Not only that, it's not even as big as the old one, and it's a stereo. That one's mono, for crying out loud. But in any case, this has a nice fluid movement. To be fair, let's do this. I've got a 0 to 50 gram tension gauge. All right, so let's take a look at this. Well, I can't hardly get on here before it starts to move. Okay, there's 10, 20, 30. Come on. You know you want to. There we go. Okay, so it's moving below 40. We'll just say maybe 38 is where it's going. This tension gauge is 0 to 200. So I'm going to use the same gauge for both faders because I want to use the same gauge to be fair. All right, so let's just try and be fair about this. And I'm pushing about 100, getting up to 150. Okay, 150, and it's budging. Okay, so 150 is where it finally breaks loose. Same tension gauge now on this fader. $50. So this one is going to feel very wonderful. These faders are electrically the same, okay? They are linear and they're 10K. Now in this one, because it's stereo, is going to have actually two wipers in there, two basically independent potentiometers in the one fader case. Got to make this fit where this one is. Now, new fader will fit well within the footprint of the old fader. However, once I get this discussion off, we take a look at it, these screw holes here, the holes don't line up, but it's going to work. And let's just pause for a second. If you'll notice, the old wiper, the piece right there, is tapered, and the new one is not. That needs to be dealt with, okay? Because the knob works great on the tapered shaft, okay? It just sets right down on there and snaps into place. Why? Well, because these little teeny teeth down here, okay, are actually going to grip this part of the wiper. And we need to maintain that. We need this knob to go all the way down and get seated. Now, the beauty of this is that that flange and the new one, okay, are the same depth, but this not being as narrow at the tip as the other one, this knob, I mean, I can stuff it in this way, but it's gonna break these little tabs off. What I'm gonna do is use a Dremel, and I'm going to shave this off, and I'm gonna taper that on both sides so that the knob will set down on there. Now, I'm not going to go ahead and, you know, notch this so that those little teeth will actually bite into there. I don't have to, because if I get this just right, then it's going to sit on there tight to begin with. So I don't actually have to over engineer this. Now, the escutcheon is only held on by 4 screws on this side. The way this actually lifts off of here, it's going to want to pivot, raise this part up over here where the screws have been removed, and then this kind of just pops off, but you've got to do it at an angle because there's a lip right here that bites onto this piece right here. This is what holds it on one side, and 4 screws hold it on the other side. These 2 screws hold the fader in, and they are screwed into this case, and that actually is what holds it to this plate. And these screws for the fader are a different length than the 4 that came out of there, although they look very much the same. I think they're the same physical thread size, but they're shorter, and you want to make sure that you don't get these mixed up with the other ones, because if they're longer, they could actually reach inside the frame too far and be a problem. So I keep those in a separate cup. So as you can see, that the screw holes are simply not going to line up. I'm going to put this frame inside this one. Okay, so in order to do that, all I have to do is take these little tabs right here and bend them up, and then just take the guts out. I'm going to clean it all out, and then I'm going to epoxy this one inside here. And once that cures and it's all done, then I'm just going to screw this back in using these screws, sans the old fader guts in favor of the new fader guts. With all the tabs bent up now, the guts should just come right out of here. Now, it may or it may not. I mean, this end is already trying to fall out. So, there we go. This is what you will find inside here. And it is, it's nasty. The signal is coming in on one end of this, okay? And it's picked up by this wiper right here, which is electrically connected to that wiper, which is much nastier than the other one. So what ends up happening is that the signal that comes in on one wiper is then translated over to the other side, which is where it comes out and goes over to the rest of the electronics that are in the actual module here. And that's the reason it's so wide, is because it's actually using 2 wipers. Now, one of these is actually going to be carbon. The other one is simply an electrical connection to take whatever value this is and translate it over to the other side so that it actually can travel on to where it's going to. So one of these is not going to have any gradual increase in resistance. One of these will, one of them won't. This fader works on virtually the same technique, but they managed to shrink it down to be able to actually put 2 of them inside there. Just take this wiper and pop that out. Now inside here, this is all, you know, because I've been spraying lubricant and stuff like that in here. So in any case, what I'm going to do is I'm going to clean all this out. Alcohol, some Q-tip wipes, and then this fader is actually going to set inside that one. Let me do that again, okay? Just like that, okay? Now we have to get it centered, We have to figure out where the center is, and we're going to epoxy that in place. Okay, but one really neat thing about how to determine what center is, well, if you look, the hole on this end is actually going to be the same distance from the end on this end. I can actually see the holes of the new fader inside the wiper area of the old fader. So I can use that just to eyeball it to get it centered. And then just let the epoxy cure. I want to make sure this is really clean so that the epoxy will actually do what it's supposed to. So this is what it looks like inside. Just little daubs of epoxy. Not so much down, way down inside by that by the opening there, the track. Okay, want to keep it away from that, but I want the fader to engage, make contact with the sides. You can actually see it kind of just float right back down into where it's supposed to be. Okay, checking this side here. Okay, and no epoxy leaking into the track. It's all aligned. Press it down, one final push. And now comes coffee time. Examination's over. Now, as I mentioned before, I need to create a taper on this shaft right here in order to accommodate the old knobs, because the original wiper had a taper. You can see the difference there. So I'm going to use a Dremel in order to grind this into a taper just like that. Before I do that, I want to make sure that the debris and the filings and all of that stuff that the Dremel is going to create, it's going to get sucked up, but I want to make sure that nothing gets down in here. What I'm going to do is take some electrical tape. So I'm going to put the actual wiper about halfway, and I'm going to use a razor, and I'm just going to create a slight opening, slip this over the tip of that shaft, make sure that nothing can get down inside there. The actual tip of this shaft, we're going to take and measure that, but it's 0.125 inches at the very top. But at the base of the taper is 0.158. This shaft is parallel, okay? And the maximum is 0.155. I just need to leave this area right down here. I need to leave that alone, but I need to create a taper that gets narrower toward the top. I'm gonna use the Dremel, and it's gonna suck. Now, I know that you watched me do this handheld, okay? But I want to point out to you, the base, which needs to remain about 0.158, the original is 0.155, is still 0.155. The tip down here, which I wanted to be 0.125, is in fact 0.125. Let's be honest. The real test is, well, how does the knob behave? That's what she said. Only perfect. What I do want to do though first is I kind of want to just make sure that I don't have any burrs on there. So I'm just going to touch it very gently. And that is number one done. Now, truth be told, I've already done the other ones. .155, 0.125. Bottom line, the knob fits. Next step is simply to go ahead and solder this in place of this wiper here. And that's going to take me all of, well, 10 minutes because I've got to warm up my solder iron. And I'll actually point out right here, there's actually 2 wires attached to this. That's because the signal from the circuit board actually goes to the fader and then continues on. So the fader is actually doing some work ahead of the rest of the circuitry. And they're the same color, so it doesn't really matter. Sorry, I just get emotional when it actually comes together. And this is good to go. So now the only thing left to do is to get these modules back where they belong. I want to go ahead and fire this up and run some audio through it. But I'm reminded of what I said a little bit ago about there being a dead channel on the studio feed output. Well, I need to discuss that, okay? Because it isn't dead anymore. I replaced the amplifier chips. These 2 chips right here, to me at least, kind of caught me off guard. So for the studio output, ultimately what had to be done is I had to replace a bad chip. And I won't lie to you, okay? They weren't easy to find. And I say they because, yeah, I only replaced one of them, but I bought more, okay? Because when you need 1, you buy 3. When you need 2, you buy 5. And I thought, you know what? I don't really know what caused that chip to blow out. I have an idea, but I figured there's 2 of them in there. I'm going to want to at least have replacements at some point in case something else goes wrong with another one. Well, here's what I think happened. In my opinion, I think what happened was because these chips are capable of delivering a signal to the studio, I think what's happened here is that those chip outputs are for driving headphones. 8 ohm maybe, 16 ohm preferably, headphones. Here's what I also think happened. I think because these are capable of feeding a speaker or speakers, I think somebody may have actually managed to accomplish that, but maybe hooked up an auxiliary amplifier to the same speaker and backfed this set of amplifiers and toasted one of them. Unless it got shorted somehow with a, they had it turned up and it got shorted. Maybe they unplugged the headphone jack while it was playing, shorted it out, blew the channel. Anything's possible. But I also want to point out, okay, because it's the studio feed output, it also doubles as a potential source for your 2-track mastering deck, because what's coming out of this studio feed output is basically whatever you've got going on the console. Inputs, groups, you've got some returns coming from effects, reverb, echo, what have you. Well, you can basically do a full-on final mix, take that output, because it has RCAs and TRS. The RCAs could be used to feed a 2-track mastering deck. It's possible. But I'll leave you with this thought. Why would you want to hook up your mastering deck to the headphone output of your mixing console? Just asking. Now, because it was a dead channel, yes, I had to replace it. Well, they solder the chips directly to the board. None of these other chips in here are in sockets. You'll notice, however, that this one that got replaced is in a socket, because when I pulled the old one out, and it was such a pain in the butt because the heat sink is actually soldered through the board. This one's in a socket. This one down here that I did not replace because it was worked, if it ain't broke, don't fix it, doesn't get an IC socket. That is until it's time to replace that one too. So let's get Jay in here and see if we can't get ourselves into some more trouble.
All right, looks like it's done.
Yeah.
You even wrapped it up for me.
Well, I just wanted to make sort of a presentation out of it, but I gotta ask, where did you find this? Okay, because there's a group of arachnidologists that wanted to get samples of the spiders that I found in this thing.
It was in a shed.
A shed.
Yeah, non-climate controlled shed in North Carolina, and that kind of makes sense that those are there. I'm guessing you took care of them all?
No, I left 2 of them in there, and they're up to you to find them.
Oh, well, show me what you got. Ta-da! Ta-da! Pretty.
Yeah.
I like the labels. Nice job.
Yeah, well, it saved on confusion.
Yeah, because there's already numbers already here, but I guess, you know.
Yeah, but they're kind of, you know, a little tiny and everything like that, and at a distance being able to, you know, just glance at it and know which knob to grab. Mm-hmm. Okay, she appreciates that.
Yeah, which knob to grab. Looks good. Looks like we found a lot more caps than I left with, so that's good. I'm sure eBay was a good find on that.
Not yet. You begin at the beginning, right?
Sure.
Okay, so put a power plug on it.
Okay.
Ran it off the bench supply, zeroed it out, put the power on, and gradually added power to it, and nothing happened. Nothing happened. The meter lights didn't come on, didn't seem to have any overload lights or anything like that. It was just, so you start at the beginning, power supply.
Cool.
All right, so.
Which, if I'm not mistaken, is actually one of these right here.
Pretty sure it's the last one.
Yeah, because this is talkback here.
Yeah, because it's a talkback module that is available for this model, but not in this particular one. Apparently you didn't empty the shed as well as you thought of.
If you happen to have a talkback module in your shed, reach out.
Let us know. Yeah. Let him know.
Yeah, let me know. I'll take care of it.
Yeah. Recap the power supply, got the power supply, got the voltages all where they're supposed to be and everything like that. So then, you know, plug it in, hook it up to the bench supply, flip the power switch, bring the power up, and nothing visual. It did pass audio, but it's workable. Channel 1 had an incredibly low level, okay? And as it turns out, it just, what I like to call elfin magic, okay? Some elves got inside there and actually changed some things.
So you've recapped all the inputs, all the modules, basically?
All the modules have been recapped, and including the power supply. But
cool.
The foil runs, you have to be so careful about the foil runs and the solder pads.
Because it's a brown board thing missing?
Well, the epoxy boards are, the foil runs, they didn't waste any amount of copper putting foil runs and printing foil runs onto printed circuits. So, you know, they're there, they're great. You create a board, put a capacitor in there, solder, or resistors, whatever, okay? But you put the leads through there, you solder it, and you leave it alone, okay? Taking that component out of there is risky.
Okay.
And it proved as much. The other thing is that basically every switch, every pot, every fader was scratchy. The scratchiness has gone away.
Cool.
Okay? So I really don't think the board had a lot of high mileage. When you've got an audio console, at least once or twice a year, I'm not going to turn it on, but you still go in there and you exercise all the switches.
Well,
you exercise switches, pots, faders. You do all that just to exercise it.
It's like an engine to a car. If you're not going to drive it, just run it once a week.
Yeah, well, if nothing else, it's just to charge the battery.
I noticed that like the caps and the buttons and all that stuff, I'm guessing you put like soap and water and washed all these up.
I removed every button, every knob, and took them down to the kitchen, filled the sink up with a mixture of Dawn and Simple Green, and just scrubbed everything. I mean, it took 45 minutes probably to go through and do that to everything. The faders, okay? Yeah, douched them and lubricated them and everything like that, and then as it turns out, just decided to go ahead and shotgun the faders and everything like that and replaced them because...
Oh, you did replace them?
Oh, yes. Yeah, no, it had to be done because...
No, hang on a minute. Oh my gosh, that's so... God, that feels like 60, 70% better.
I remember you working on something where you were actually mixing with this before we actually got it.
Yeah.
Before we did the faders. All the other work was done.
Yeah.
But just using the faders, it was like, as I've said before, it was like rubbing two bricks together. It was like...
Yeah.
It was just...
Oh, that's original though. The Master's original. Okay.
The Master is original, and actually that's a good way to compare the two.
Yeah.
But the Master is original because, yes, these were mono faders. These were actually replaced with stereo faders.
Sure. At least I'm guessing the ones that you found that fit.
Yes.
Okay.
But the Master fader,
4-gang.
that was the deal breaker, because the Master fader is a 4-gang, 4 wipers fader.
Yeah.
So
that makes sense.
But here's my thought.
You're not going to move that very much.
The Master's going to be set it and forget it.
Basically.
Okay. So
you can do everything. You can do everything here on the buses, anyways.
I go to push the fader, and the board, because I've got it on a Lazy Susan, it moves. Whereas, to be fair, if I go over here, all right, I hit it with my fingernail. Nothing there, and yeah.
Sweet. Okay.
But that's not atypical of TEAC. I don't really have a problem with a lot of TEAC gear, especially the old stuff. But the not so direct outs.
Oh yeah.
Okay. The direct outs. The back panel of this thing has direct outs for each of these channels. Okay. So the idea is that a direct out is basically whatever you put into this is available at a output without necessarily being affected by a fader or the EQ.
Okay.
Not so.
So
the direct outs on this board, basically the up position was off.
Yeah.
The direct out was shorted out. It was basically shorted out so that there was no stray signals.
Wait, let me get ahead of you now. You modified it pre and post fader.
Oh yeah.
That's actually really cool. Because when I read the manual on this, I was actually very concerned because there's a future for this system. And the 80-8 that we just fixed, this M5, I was kind of mad that they designed it that way, and I'm very happy that you actually got that resolved, because now that means that whatever I pre-insert.
Oh, even better.
Even better than pre-insert.
Push the button down and it works just like you would. So somebody's TEAC experience knows to push that down. It's going to be post fader, post EQ. Yeah. But now when the button is up, it's pre-fader, pre-EQ.
Got it.
Down is post fader, post EQ.
Okay, so there is a downside that I can immediately think about.
Okay.
It's not like, it's up to the engineer to do it right. The only downside that I see is that since I can switch from line to mic on these inputs, right? So mic input, tape input, the 80-8 playback. If I don't have the 80 in repro mode, I could backfeed the 80. If I have this in pre-fader,
yes,
and then I have that in input mode, the 80 in input mode, I could backfeed the 80. Because whether it's switched to line and mic, that's still going to take on the direct out.
Okay.
So that's the only real downside that I can see. But there's a real easy fix for that. I hit the green button that we have on our 80, repro, playback, and then it's a done deal.
Okay.
So that's the only downside that I see, but that's a huge upside to where I can have like inserts and stuff like that and not have it be recorded.
By having a raw output to the directs and it be selectable that now what goes to tape is raw, can be fixed in post.
Post preamp, basically. That's actually a really, really cool mod. I'm actually kind of excited to edit the video on that because that's actually really cool. Let's see. So,
I mean, it's ready.
dude, you just like
ready to go.
it changed my whole perspective because I was thinking about, like, if I ever wanted to record anything on this, I would have had to figure out like a mixing style, because that Resolved is basically like I would have to insert the processors via the inserts that it has, and then shut them off, record, and then play back, and then
turn 'em back on.
turn the processors back on. But that also means that the band on stage would have unprocessed audio on their recording, which sucks. Just so I could have post
Yeah, 'cause
control.
They're not going to get the dynamic.
No,
they're
not
not going to
anymore.
get the feel of the actual song.
That saves this console pretty greatly. I'm very excited that's been fixed. Okay, can we turn it on?
Yeah, yeah. I don't even need the bench supply because I trust it.
Oh,
Don't you just love that sound?
that actually, I really like the way you did the strips.
I mean, I did everything I
Yeah.
could to make it look like the the lamps, the incandescent lamps that were in there,
Yeah.
have been duplicated. What I wanted was uniform lighting all across the bottom, but I also wanted the same color.
Yeah.
I wanted the same color.
And they're yellow.
That's what I'm talking about.
Like, I've seen a lot of modifications, and no disrespect.
It just looks incandescent.
No, they're blue, they're purple, they're other colors, they're like RGB colors, and I'm just like, this is a 1970s device. Like, yellow lighting is the best lighting.
Because it was incandescent.
Yeah, well, that's the
And it's-
thing.
I mean, that's what, maybe 2,500 Kelvin, 23?
It's yellow.
No.
That's the thing. It's not another color. It's a color temperature light color. I love these faders. This is
Well, I'm
super.
glad.
This is super cool. Okay.
I just want to bring up one little thing, okay? I mentioned before, the studio feed had a dead channel.
Okay.
All right. And the studio feed is kind of weird because I think they're just giving you a lot of flexibility. First of all, the studio feed has a pair of RCAs, left and right, which are hardwired to a TRS headphone jack. And the confusing part was that in the documentation, that TRS RCA configuration is supposed to be minus 2.2 dB.
Okay.
All right. The control room output, which is a different set of RCAs, is also minus 2.2. But they're using a dual op amp for the control room, and they're using separate chips for the left and right for the studio feed, and they're the same chips that get used in boom boxes from this era. 2.5 watts coming off the back of this. And my initial thought was, well, the studio feed is probably what you'd use for your 2-track mastering deck.
Yeah.
But apparently, that output is for headphones. But not the control room headphones that the engineer is wearing, but a completely independent headphone output that'll drive 8 ohm load, or up to a 16 ohm load, up to 2.5 watts.
Yeah, because I noticed there is a headphone jack here. So there's another headphone jack on the back of this.
There's a headphone jack here.
Yeah.
Okay? And then there's a headphone jack on the back side, which is independent of this, because this headphone jack is that knob, it's assignable, but then the studio feed is assignable with a headphone jack.
2-track deck on studio output. Why not?
You could, but then, who in their right mind would hook up their 2-track mastering reel-to-reel deck to the headphone output jack of an audio console?
Well, amplifiers are better at noise rejection versus an op amp.
Well, I can tell you this, the chips have a lot of extraneous outboard feedback components to keep it really, really clean.
I'd feel a little more comfortable with that. I would need to run tone. I need to run tone and make sure that I'm not going to blast out my inputs.
But I also looked at the specs of those chips, and the noise floor is about 55 dB.
So 15 dB louder than standard tape.
Yes.
So deep.
Do I want that on my master tape? Maybe not.
Well, that's if you're at 0 with it, yeah? Or is it always if you have it on a low trim?
Put it this way: turn all the audio off with the deck turned on, with the board turned on. Your noise floor is going to be 55 dB.
Yeah, because if you start adding trim and you
preamps in this thing. Now that said, this is 1976.
Yeah.
Noise floor wasn't so much a thing because of the technology wasn't really capable of it until you started getting into MOSFETs and the like. So there is going to be a noise floor.
Sure.
By the same token,
It's analog.
it's analog. I love that. Okay,
So whatever, man. Okay, like that. Brush that one off. Cool. So control room is for control room speakers.
control room output is a line level output.
Yeah.
Okay. To feed an external auxiliary amplifier to your control room monitors.
Okay, and then studio is 2 tracks / a 1 watt headphone jack.
2 watts.
2
But
watt
yes,
headphone jack, and then a 100 milliwatt jack out front.
right, which is that headphone for selecting whatever.
Okay.
Okay. So
Can we
Yep.
can we play some music? I'm guessing you got me set up for music.
I am ready for a full-on demo.
Cool. I won't take up much more of your time then. So,
Okay.
all right, play me some music. Let me see what we got going on here.
Well, I thought I would treat you to some familiar music.
Oh, I know this song. So everything works.
Yes.
Great.
Now we could patch into all of the other inputs and everything like that. We're just using 1 and 2 right now. But what really got my attention was the fact that you were making changes and switching in the EQs and stuff like that, and it's totally quiet.
Yeah.
No scratches, no
Fair.
dropouts. Okay. So it's ready to go.
Well, that's good.
So do something with it. Make me proud.
Yeah, there's definitely something in the works. It's gonna be ridiculous. It's gonna be very far-fetched, and wait till you find
That's
out.
I think that's one of the 6 R's, is it?
Yeah, ridiculous. Wait until you find out what I've been building at my house, because tune in. That's all I can really say. It's gonna be exciting. It's gonna be really cool.
Definition. Scary.
A lot of work. A lot of work.
Well, love you.
Love you, Dad.
And that's one more piece of recording history ready for another generation of music. Nearly 50 years after it left the factory, the TEAC Model 5 is cleaned, repaired, and ready to get back to doing what it was built to do in the first place: make music. If you enjoyed this restoration, consider subscribing. There's still a few surprises ahead, big ones, and this console has plenty more stories to tell, trust me. Thank you for your time this time. Till next time, be well.